Hello, welcome to the IOT Smoke Detector project. I'm Abdullah Al-Ammari, the designer of the Android phone application block, the database and server block, and the buzzer circuit block.
And my name is Muhammad Bukshaysha. I'm responsible for the voltage measurement block, the Wi-Fi module block, and the enclosure.
And my name is Mustafa Al-Namir. I was responsible of the microcontroller block, the voltage regulation block, the power supply block, and the sensor block.
Many of you have definitely witnessed an event of an active alarm. This event could be hazardous, containing fire, smoke, or gas emission. Or it could be simply because you were cooking with your family for a day or at your apartment. In some of the situations, people would like to stop the active alarm when it's unnecessary. Unfortunately, a lot of the commercial smoke detectors do not offer this type of control. The IOT Smoke Detector project, we believe that we could fix this issue along with adding multiple features. The IOT Smoke Detector is a microprocessor-based device that has the ability to be controlled. It has a dedicated phone application and the user is capable of controlling the IoT Smoke Detector through this phone application wirelessly via Wi-Fi. Some of the features in the IoT Smoke Detector is that it can be set to 2 sensitivity levels, high or low. It could also be stopped when there is an active alarm. It could also send low battery notifications along with sending active alarm notifications.
The IoT smoke detector should have 2 sensitivity levels, low and high. The user should be capable of choosing either through phone application.
The project total cost should be less than $300. In our project, the system was around $270.
Ability to receive low battery notification. The IoT Smoke Detector should be able to detect when the battery is low in power. And as soon as it detects that the battery is low in power, which is 7.4 volts in our case, it should send a notification to the phone application.
The IoT smoke detector alarm can be snoozed for 15 minutes as gas is sensed and notification is sent to the phone application. The user should have the ability to choose a snooze option, which will turn it off for 15 minutes.
The size of the device should be less than 15 by 15 by 15 centimeters. The closure size were 11.5 for the length and width, and 7.5 for the height.
The smoke detector should detect gas and smoke. And as soon as it detects the gas and smoke, it should send a notification to the phone application to notify the user that there's an active alarm.
The IoT smoke detector is powered by a 9-volt battery. The battery that we chose is a 9-volt 522 Energizer battery. The reason of choosing it was it's widely available in the market. It provides the system with ranges between 7 and 9 volt. It has a capacity of 500 milliamp hour ranges.
The IoT smoke detector should be less than 100 grams. We managed to make it around 360 grams.
The IoT smoke detector should reach 80 dB within a distance of 30 centimeters. Fortunately for us, we've been able to reach 100 dB at a distance of 30 centimeters. The dedicated Android phone application should have an easy-to-use human interface. This is accomplished by providing the user with 3 windows: a main window, a description window, and a control window. We have decreased the amount of buttons and the complexity of the buttons for the user to 4 buttons. A snooze button or a stop button, a low and high buttons for the sensitivity level, and a stop battery notification button to stop a battery notification alarm.
the sensor block, we used MQ2 gas sensor, which is highly sensitive to ranges of gases such as hydrogen, propane, methane, and some other gases. It sends an analog signal to the ADC channel in the Atmega 128. It operates in normal room temperature.
The database block is a block that represents a link between the Wi-Fi module and the phone application block. It is extremely difficult to accomplish direct communication between the two blocks. Therefore, we had to use a database. We have raw PHP files for both the Wi-Fi module and the phone application blocks. Those PHP files allow the Wi-Fi module or the phone application to update the database or receive updates from the database and read them in JSON string format.
The Wi-Fi module block is responsible for the communication between the phone application and the microcontroller. We are using the RNXV Wi-Fi. We are using two of them. One will be for sending data from the microcontroller to the phone application, and the other is for the other way around. We chose this device specifically for the low current consumption. One of the devices, the one that sends data to the microcontroller, this device checks the database every 15 seconds. And the other one is once, for example, the alarm is on, the microcontroller will send, let's say, one for the RX Wi-Fi, and then it will update the database. And then the phone application will know that there is an alarm going on.
The Android phone application block is really a code block. We have used Java programming language along with libraries from Android Studio. What the phone application does is that it receives and sends updates to the database. It scans the database every 3 seconds, and it could update the database instantly when the user chooses a command. The commands are like snooze, low or high sensitivity level, or stop battery notification.
The microcontroller block, we used Atmega 128 as our microprocessor. Atmega 128 is very powerful development model. It receives the sensitivity levels and snoozing option from the Wi-Fi module through UART RX board. Depending on the choice of the user, it alters its function. It sends notification in case of alarm or low battery to the Wi-Fi module through UART board. It monitors the sensor level and the live battery level through ADC channel, and it sets port B as high in case of alarm.
So this is the enclosure for our IOT Smoke Detector. As you can see, the buzzer is visible, and also there is gaps in order for the gas to be sensed. And you can see that it's square shaped, where it is 11.5, 11.5, 7.5 in dimensions, and also it can be attached to our wall.
So this is the IoT Smoke Detector phone application, and what you're looking at right now is the main window. The main window has the welcoming text, and it has two buttons. It has a button that transfers the user to the description window, and a button that transfers the user to the control window. So if we would go first, press on the first button for the description window here. You would read the welcome. There's a welcome prompt and all the instructions on what the app does and how the IoT Smoke Detector operates. We could go back by pressing this button. Then we would get us back to the main menu, we would go to the control window. And here is the alarm on. All of the buttons that you could see, like snoozing the button or stopping the alarm. Sensitivity levels, low, high, and stop battery notification. When there's a low battery, you could just stop it right here. And here, as you could see, there are there's a fire alert right now. So we press here, and in this situation, even if we were in the main window, it would transfer us to the control window. So at this point, we could stop the alarm by pressing on the snooze button. That's good. So right now, we're exposing gas to the IoT smoke detector. We're weighing, and here's a distance of 30 centimeters, and this is a dB measure. So we put the max. As you can see here, the max reached 90 or 100 dB. So at a distance of about 30 centimeters or even more from this distance. At this point, we would go to our phone and we would see the notifications, fire alert. It would take us to the control window. We would simply snooze it. After we snooze it, we could see that there is some notification. Sorry.
And when we expose gas now, we see the alarm is off.